Okay, so in this question, I've been presented with this equation. So we've got Li plus HCl produces LiCl and H2, and in effect, I've been asked to try and balance this equation and also make sure that in the final equation that these are actually only whole numbers being used to kind of create the balanced equation at the end. Okay, so how am I going to approach this? Well, the first thing I'm going to do is I'm going to do an audit. I'm going to ask myself, well, how many atoms of each element do I have on the left hand side, so on the reactant side, and on the right hand side, so the products side. So that's going to be simply, I'm going to abbreviate that, left hand side and right hand side. Okay, so what do we have? We've got Li, we've got hydrogen H, we've got Cl. Well, we don't literally have hydrogen, but we do have the element hydrogen, but you know, anyway. Okay, on this side we actually do have hydrogen as a molecular hydrogen, but Li H Cl okay, so for Li we've got one, right? So you can see we just got one on this side, and it's the same for all of them basically. HCl is just one hydrogen, one Cl, and on this side LiCl, so we've got one Li, we've got one Cl, but then for H we've got H2, so that's going to be 2. So you can clearly see that at least for the hydrogens, this is not balanced. So we need to actually try and progress this to a state where it is balanced. Okay, so if we first try and confront the inequality of the hydrogen, one of the ways we can approach this is by putting a 2 in front of the HCl on the left hand side. Because I mean, we've got more hydrogens on this side. We've got, you know, this is the only species on the left hand side where we do have hydrogens, so that's why we can try and adjust that. And if I add that to the new equation I get is what? Well, it's going to be Li plus 2HCl produces LiCl plus H2, right? And so I'm going to do an audit of this, and remember we did not change anything on the right hand side, so that's going to be the same. Okay, so that's literally just going to be Li. For our numbers, it's going to be the same, so it's going to literally still be 1, 2, 1. Okay, now on the left hand side we did change stuff, so we added the 2 HCl, so it's gonna change some of this. So here, because we added a 2, for hydrogen we're gonna have a 2 now, and for Cl as well we're gonna have a 2, and for Li we didn't change that, so it's gonna still be 1. Okay, so as you can see, our hydrogen is, we've got 2H here and we've got 2H here, so that's now in effect arguably balanced. However, for other elements, for the Cl, it's not balanced. Okay, so that creates an issue. So how can we, and where we have the deficit, it's actually on the right hand side. We have got one less on the right hand side, and the only species on the right hand side that contains the Cl is the LiCl, right? So what I'm going to do is add a 2 in front of the LiCl. Okay, so, and if I add that 2, we get a new equation. So the new equation is effectively, well, I mean, get new coefficients anyway, plus 2 HCl produces 2 LiCl. Right, so this is what I've added a 2 here, in contrast to this, plus H2. Okay, now again on this side we've not changed anything, so this is going to be the same as it was before. So if we do that, LiHCl, it's literally just going to be the same. So 1, 2, 2. But on this side, well, of course, we put a 2 before the LiCl. So for the right hand side, we've got LiHCl. In effect, what we get here now is going to be Li, we've got 2, right? For Cl, we've got 2 as well. And then for H, we've got 2. Okay, so what do you notice? What we notice is that now the H's are balanced, the Cl's are balanced, but the Li is not, right? So we've got 1 on the left hand side and we've got 2 on the right hand side. So how do we fix that? It should be quite clear how we can fix that, right? I would invite you to kind of have a go at what you feel we may need to do, what you think about that. But it should maybe perhaps be quite obvious that at this stage what you can do is just put a 2 in front of the elemental lithium, and that would basically give us a 2 on that side, right? So if we do that, effectively we'll get 2 Li plus 2 HCl produces 2 LiCl plus H2. And again, on this side, we've not changed anything. So when we do our right hand side auditing, we get the same as what we had previously. So get right hand side for Li, we're going to have 2. For hydrogen, we're going to have 2. For the Cl, we're going to have 2. So this is literally just the same thing, right, as what we had before, because we didn't just change anything here just now. On the left hand side, we added something. We added a 2 in front of the Li. So Li is now different. So instead of it being a 1, we're going to have a 2. But as far as the H and the Cl goes, we didn't actually modify the HCl species compared to what it was before, right? So those numbers are not going to change either, right? So it's going to be a 2 and that's going to be a 2. Okay, now if we now compare left hand side and right hand side, what do we see? Well, what we see is that the value of effectively the occurrence of each element is the same now on both the left hand side and the right hand side. So we can reasonably confidently we can say yes, at this stage is balanced, and the specific requirement that it needs to be only whole numbers is also met. Okay, so we can effectively say that at this stage, you know, put in the numbers, we can say 2 here, a 2 here, and a 2 here, and voila, it's balanced. Okay, so I hope that makes sense, and as we've determined, this is our balanced equation. Okay.